on problem 10.67, I went through this a minute ago and didn't have the record button on. And gee, I hated to go ahead and erase all this and start over. So I'll just talk you through the problem as I've written it down here. What we have is a person on a motorcycle. The mass of the person is given, and the mass of the motorbike is given, and the moment of inertia of the two wheels is given. And this person's riding on level ground at initial velocity of v, but it encounters a hill. Now, under the assumption that it's not going to be, you're not going to apply any power, you're not going to hit your brakes, you're just going to use uh, the energy of the bike here, and you're going to try to determine how high the bike plus the passenger will rise, and we'll call that distance h. So the mass of the bike is given, and the mass of the velocity of the bike is given, the mass of the bike, and the mass of the person. The radius of each wheel is 0.26 meters, and the moment of inertia of each wheel is 2.1 kilometer meter square. And we're looking for the height that it goes to. Now, this is a conservation of energy problem in which the energy that you start with equals the energy that you finish with. Remember that we're going to put in the kinetic energy in terms of the mass of both objects, okay, the bike and the person, okay? So that's what M will be when we write the conservation of energy equation. Now the solution, when you look at the energy that you finish with, that's going to be a final potential energy. It'll be gravitational potential energy. And that will be equal to the kinetic energy translation of the bike plus the kinetic energy of rotation of the wheels. We have to use some energy to spin those wheels. Okay, so what we do then is just actually start plugging in the values for each of those terms. The final potential energy will be mgh. The translational kinetic energy is 1/2 mv squared. Remember, that's the total mass. And then we have two contributions to the kinetic energy that the wheels will lose. And so each wheel has kinetic energy of I omega squared over 2, but I have two of those. And remember, since this is rolling without slipping, omega is related to the velocity in this manner right here. So we can take this expression right here and replace it for omega squared, and that's what I've done right here, keeping everything else the same. All we have to do now is just a little algebra, and what we're looking for is the expression for h, okay? So we have to factor out the velocity squared, and then if we isolate h, we end up with this expression right here, in which you can then plug in the numbers to come up with the numerical value for how high this thing rises up the hill.